Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session we are going to discuss about classification of elements and periodicity in properties from JEE Mains 2024 questions. So let us start now. Here we have the first question. The correct order of first ionization enthalpy values of the following elements is. Here the given the elements oxygen, nitrogen, beryllium, fluorine and boron. So given elements just you arrange in the increasing order of their atomic number. Okay. So which one will come first? Which one will come first? Boron, yes, hydrogen, helium, lithium, beryllium. Next boron will come, beryllium, boron. Next one carbon is not there, nitrogen, oxygen, fluorine. Okay, these are the given elements. Okay, beryllium, boron, nitrogen, oxygen, fluorine. Okay, now you have to arrange in the increasing order of their ionization energy. Okay, can you tell what is the atomic number of beryllium, hydrogen, helium, lithium, beryllium? 4 means its electron configuration is 1s2 2s2. Yes or no? So this is fulfilled configuration. Beryllium has fulfilled configuration. Next boron will come. So boron electron configuration, the last electron configuration of boron is 2s2 2p1. This is a valence electron configuration of boron. Beryllium, boron, carbon is not there. Next nitrogen. So nitrogen electron configuration is 2s2 2p3. Okay, it has off-filled configuration. Okay, those elements which are having fulfilled configuration or off-filled configuration has more ionization energy than next element. Okay, then oxygen electron configuration is 2s2 2p4 and fluorine electron configuration is 2s2 2p5. Now you tell among all these elements which one is having a fulfilled configuration? Beryllium. So beryllium has highest ionization energy than next element, then boron. Okay, beryllium has highest ionization energy than boron. Okay, across the period what happens? The size decreases. As size decreases, ionization enthalpy values increases. Yes or no? Here exception cases, because of the fulfilled configuration, beryllium has more ionization energy than boron. Next, this is nitrogen. Nitrogen has off-filled configuration. Because of off-filled configuration, nitrogen has more ionization energy than oxygen. Okay, then you arrange in the increasing order of their ionization energy. Now you see, first boron will come. Okay, so what is the next one? Next element is beryllium. After next element, boron, beryllium. Afterwards, which one will come? Oxygen. Next, nitrogen. Next one is fluorine. Now you tell which order is matching here. So boron is E, beryllium is C, right? C, oxygen A, so nitrogen is B and fluorine D. Okay, E, C, A, B, D. So your option 2 is matching. Yes or no? And this question given in JEE Mains shift 1 paper and April 2024 exam, and this question given. Okay, and okay. So given below are the two statements. Statement 1, the correct order of first ionization enthalpy values of lithium, sodium, fluorine and chlorine is like this given. Okay, and read one by one, and in this statement 1 and statement 2 you have to select which one is correct, which one is not correct. This is assertion region type questions. So statement 1, not assertion region, but statement 1 given, statement 2 given. So we have to select which one is not correct and which one is correct. Okay, so now you see the correct order of first ionization enthalpy of lithium, sodium, fluorine and chlorine. The given elements just you arrange in periodic table, like periodic table order. So now you see lithium will come in the first order. Yes or no? Lithium. After lithium, sodium first group element. Okay, and where the fluorine, chlorine will come? Here in the 7th group. Fluorine, chlorine, here it will come. Now you tell among all these elements which one is having lesser in size? Fluorine is having lesser in size. Why? Because across the period what happens? Size decreases. Now lithium, when you move on to the move across the period, the size decreases, means fluorine has lesser in size compared to the lithium, means in period ionization energy values increases. Yes or no? In period ionization values increases. So fluorine is smaller in size, so it has highest ionization energy. Then fluorine will come last, right? It has highest ionization energy. Okay, and this side elements are having highest ionization energy. After fluorine, next chlorine will come. Okay, so next in lithium, sodium, Which one is having lesser ionization energy? Which one is having more ionization energy? Okay, down the group, what happens? The size decreases, ionization energy also decreases. From fluorine to chlorine, fluorine has highest ionization energy than chlorine. Okay. Similarly, in lithium to sodium, sodium has less ionization energy than lithium. Why? Because the sodium size is more compared to the lithium. Yes or no? Next, which one will come? Sodium or lithium? So lithium will come. Lithium has somewhat highest than sodium. Then sodium has having least ionization energy compared to the lithium, and this is a right order. Yes or no? And across the period, size decreases, ionization energy values increases. Now you see, compare fluorine and chlorine. Down the group, what happened? Size increases. If size increases, ionization energy values decreases, right? That means the fluorine has more ionization energy than chlorine. So this is over. In these two elements, which one is having lesser in size? Lithium is having lithium has lesser in size, so it has more ionization energy compared to sodium. Okay, the order is this one. So the order also given here, right order. This is the statement 1 also. Statement 1 is true. Then statement 2 also we have to check here. The correct order of negative electron gain enthalpy values of lithium, sodium, fluorine and chlorine. Already know that first year group elements ready to lose the electrons. They don't want to take the electrons. Yes or no? The electropositive elements has negative electron affinity values. Remember, the electropositive elements are having negative electron affinity values because they don't want to take the electron. They want to lose the electron readily. Yes or no? Means these are the lithium and sodium. Okay. Who can readily donate the electrons? Yes, can you tell? Yes, very good. That is sodium. Why? Because size down the group, what happened? Size increases, then nuclear attraction force on the last electron decreases. So electron it can readily donate. So the size, which one is having more size, that can readily donate the electron, that cannot take the electron. That means it has more electronegative value. That means not the electronegativity. Electron affinity values are negative values. Okay, the electropositive elements are having negative electron affinity values. Remember like this. They don't want to take the electron, but they can give the electrons readily. Means sodium has negative electron affinity than lithium, right? Already you know that which one is having more electron affinity values among the periodic table? Chlorine. Chlorine is more electron affinity value. In fluorine and chlorine, chlorine has more electron affinity value. They can take the electron readily. Why? Because they have some vacant orbitals. They can readily accept the electrons compared to the fluorine. Means chlorine has more electron affinity than fluorine. In lithium sodium, then lithium will come and sodium come to here. Okay, means electron affinity value increasing order when you arrange like this. Down the group, size increases, then electron affinity values decreases, right? So the given statement, both statement 1 and the statement 2, both are true, right? Here answer is 1 is matching. Okay, actually in groups, second period or third period, it is fluorine and chlorine. Can you tell? And this is the second period and this is the third period. Third period element has more electron affinity values than fluorine, right? But in the exception case, this is the first year group elements. These are the electropositive elements. Electropositive elements, they don't want to take the electron readily. Okay, sodium can give the electron very easily, but it cannot take. But that means it has a less electron affinity values. These are the negative values than lithium. Is it clear, everyone? Okay, and both statements are correct. Both statement 1 and statement 2 are correct, and this question given in JEE Mains 4th April 24 in shift 2. Okay, and move on to the next question. And the next question, here we have the isoelectronic species they given. Okay, you read the statements and given statements, which statements are correct. All of you please try this. Please pause the video and try to solve this. Okay, now you come to your, the statements are the statement the correct about the species O2 minus, F minus, Na plus and Mg2 plus, and these are isoelectronic species. Isoelectronic species are having a same number of electrons. Okay, and here we have the O2 minus. O2 minus means oxygen atomic number is 8. 2 minus means after absorbing 2 electron, after gaining the 2 electron, then it will become O2 minus. Okay, what is the atomic number of the oxygen? 8. After gaining 2 electrons, the electron number become 8 plus 2, it will become 10 electrons. Means it gains the electron, means the size increases. And O2 minus has more in size comparatively F minus. Okay. Then fluorine. Fluorine atomic number already you know that is 9. The fluorine gains 1 electron, means the fluorine will become fluoride ion like this. After gaining 1 electron, it also has 10 electrons. Means oxygen gains 2 electrons. That is why it has more in size compared to fluoride. Now coming to the sodium and magnesium. Sodium atomic number already you know that sodium atomic number is 11. To get a 10 electron configuration, it has to lose 1 electron. Means those elements which are losing the electron, the size decreases. If atom gains the electron, size increases. If atom lose the electron, size decreases. So it lost 1 electron. So then sodium comes here after magnesium. So now you see the magnesium. Magnesium atomic number is 12. To get the 10 electron configuration, it has to lose how many electrons? 2 electrons. Yes or no? 12 minus 2, 10. Means it will get monopositive and it is dipositive. This is a decreasing in size of the ions. Okay. The atoms which gains the electron, size increases. The atoms which loses the electron, size decreases. The sodium loses 1 electron, magnesium loses 2 electrons. That's why magnesium 2 plus ion is lesser in size compared to sodium. Okay. Now you read all the statements, and A statement is correct or not? Yes or no? All are isoelectronic. Yes. All are having 10 electrons, and this is the right statement. All have the same nuclear charge. No. The nuclear charge means nuclear charge here 2 minus is there, F minus is there, Na plus is there, magnesium 2 plus. The charges are different here, and this is not correct statement. Okay. Now O2 minus has the largest ionic radius. Yes. Among the all ions, which one is having more in size? O2 minus is having more in size. Then the size is more. O2 minus has the largest ionic radii compared to the all other elements. Then among given ions, which one is having lesser in size? Magnesium 2 plus has lesser in size. Now it is also correct, right? And what are the correct statements here? A, C and D. So which one is matching here? Option 4 is matching. This option 4 is a right answer. Is it clear, everyone? Okay, and move on to the next question. In the next question, this is given in 5th April 24 mains 6 to 2 exam. The correct statement from the following are the decreasing order of atomic radii of group 13 given. Okay, already just now we discussed it. Third group elements radius: boron, aluminium, gallium, so next indium and thallium. Okay, now these are the exception case. Gallium has lesser in size compared to aluminium. Why? Because due to poor shielding of d electrons, the nuclear attraction force on the last electrons increases, so size decreases as compared to the aluminium. Means after boron, gallium will come, next aluminium. Actually down the group what happens? Size increases. After aluminium, which one will come? Yes, next indium is there, next indium, afterwards thallium will come. This is the increasing order of atomic size, but it is given in the reverse order. Okay, you just arrange in the reverse order: thallium, indium, aluminium, gallium. So this is the least atomic size, boron. Boron will come last. Okay, and this is correct statement only. This is correct statement. The given A statement is correct. Okay, now come to here. Down the group 13th electronegativity decreases from top to bottom. Is it correct? Is it correct? Can you tell the size decrease in size? What is the difference between the, what is the relation between size and electronegativity values? Can you tell? Yes? No, it is not correct. Why? Because size is inversely proportional or directly proportional. Electronegativity means the atom which is having which has lesser in size, it has more electronegativity value. Means atomic size is inversely proportional to electronegativity values. But here given that down the group 13 means boron, aluminum, gallium, indium, electronegativity decreases from top to bottom. Electronegativity is decreases, but not in correct order, not in like this: boron, aluminum, gallium, indium. But so in this way it decreases. How it is decreases? Boron has more electronegativity than gallium, next aluminium will come, and this is the indium, this is a thallium. And this is the electronegativity order of 13th group elements, but not exactly boron to aluminium, aluminium to gallium, not like that. So after boron, gallium will come, next aluminium, indium, next thallium. But the given statement, is it correct or not? No, it is not correct. Why? Because here gallium has some exception case, right? So it has lesser in size compared to the aluminum. The atom which is having which has lesser in size, it has more electronegativity. Yes or no? Next, that is not correct statement. B is. Next one is what is that? Next one is that, yeah, aluminium dissolves. But this is also not correct, I think. Sorry, this is also not correct. Why? Because after boron, aluminium came here. So after boron, gallium has to come. This is also not correct. A option also not correct. B option also not correct. Why? Because after boron, here aluminium is there, but after boron, gallium has to come here. Okay, this is also not correct. Aluminium dissolves in dilute HCl and liberate hydrogen, but concentrated HNO3 renders aluminium passive by the forming protective oxide layer on the surface. And this comes under third group elements, P block elements. Okay, and it is there that when aluminium dissolves in the dilute HCl, so aluminium, when it is dissolved in the HCl, it liberates hydrogen gas, AlCl3 form, and it also liberates hydrogen gas. Okay, and this is a not balancing equation, we have to balance, and this is the equation, this is correct only. When aluminium react with the dilute acid or concentrated dilute acid, it liberates the hydrogen gas like this. Okay, now but in concentrated HNO3 renders aluminium passive by forming protective oxide layer of the surface. Okay, aluminium, they do not wait just a minute. When aluminium, when it is react with HNO3, can you get any products? No, we cannot get any products here. Why? Because of this oxygen, HNO3 has oxygen. Because of this oxygen, aluminium forms one oxide layer on its surface, and because of this, it cannot further react with the acid. Okay, and the given statement is correct. So answer C is correct here, right? Next one, all elements of group 13 exhibit highly stable +1 oxidation state. Yes, is it correct? All elements are not exhibit highly +1 oxidation state. Down the group, +1 oxidation state value increases due to inert pair effect, and this will comes under the P block elements. Okay, and this is not correct. All elements does not show the +1 oxidation state. Only down the group, indium, thallium, the +1 oxidation state increases. The stability of +1 oxidation state increases down the group, and it comes under third group element. There we can read there. Next one, hybridization of aluminium in aluminium H2O6 3+ ion is sp3d2. Yes, this is a sp3d2 configuration only. Why? Because it has 6 aqua ligands. So it has S1p3d2, total 6. The hybridization of aluminium H2O6 3+ is sp3d2, and option C and E both are correct. So here option C and E both are correct. Answer 1 is matching. Okay. Okay. So in this question, evaluate the following statements related to group 14 elements for their correctness. Covalent radius decreases down the group from carbon to lead in regular manner, but already you know that down the group size increases, not decreases, due to increase in the orbit number, size increases, but here given decreases. Is it correct? No, it is not correct. Next one is electronegativity decreases from carbon to lead down the group gradually. It is given like that, but carbon to lead electronegativity values not decreases. Why? Because these are the atomic radius values of 14th group elements. Carbon atomic radius value is 77.2. Now you see silicon, germanium both are having the similar in size. Because of the similar in size, and these elements are similar in electronegativity values, and down the group size increases, electronegativity values decreases from tin to lead, but not gradually decreases. But silicon, germanium are having lesser in similar in size. Because of this, it has same electronegativity values. So this is also not correct. Okay, next to C, maximum covalence of carbon is 4. What is the valency of carbon? Valency of carbon is 4. It can bonded with 4 other atoms. This is correct. And whereas other elements can expand their covalence due to presence of d orbital. Yes, this is correct statement. So when you move to carbon to silicon germanium, the d orbital availability of d orbital increases. Due to that, the valence number also increases. This is correct statement. Heavier elements do not form p-pi bonds. Yes, this is also correct. Only smaller elements only form the p orbital bond. Heavier elements are having d orbital starts from the heavier elements, right? So they can form d-pi bond or d-pi bond also. But only smaller elements only form the p-pi bonds. But heavier elements do not form the p-pi bonds. So this is also right statement. Carbon can exhibit negative acceleration state. Yes, this is also correct. So carbon in RMGX, magnesium halides. R means you take CH3. This is comes under organic chemistry. So here magnesium means this is a magnesium donate the electron. Why? Because magnesium is electropositive element. It can readily donate the electrons. Magnesium belongs to second group. It has +2 charge. Means it donates the 2 electron to carbon atom. Then the carbon will get negative charge and magnesium will get positive charge in RMGX. So this is also correct. So carbon can exhibit negative oxidation state. So which one is right option here? C, D and E. And C, D and E. Where it is coming here? In option 1. So option 1 is the correct option. Is it clear, everyone? Okay. Then move on to the next question. Okay, and this is the list 1. You have to match with list 2. And these are the elements: fluorine and oxygen, chlorine and sulfur, germanium, arsenic, francium and radium, fluorine and oxygen given. Now you see chlorine and sulfur, which one is matching? And fluorine, already you know that most electronegative elements, fluorine and oxygen are most electronegative elements. You see this fluorine and oxygen matching with here where elements with highest electronegativity. Means here D is matching with 1. Okay, these are the highest electronegativity elements. Okay, elements with largest atomic size. Which one is having largest atomic size? First A group elements. Down the group size increases in that hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. And in the second group, radium is there. And these two are having highest atomic radius compared to all other given elements, right? So here second option, it is matching with 2. Such as C, francium and radium. Francium and radium are having elements with largest atomic size. Okay. Next one, elements which shows the properties of both metals and non-metals. Okay, C with 2, D with 1, and already we know that this is the right option. Yes or no? Now you see here germanium and elements which shows properties of both metals and non-metals. That means metalloids. These two are the metalloids. Germanium and arsenics are metalloids. Here B is matching with 3 and the remaining A. Elements with highest negative electron gain enthalpy. So chlorine has electron affinity, more electron affinity values. So A here matching with 4. Okay. So this is the correct option. Yes or no? Okay. Now you see the answer here 3 is matching. Clear? Right. Now next question. Identify the correct statement about p block elements and their compounds. Okay. Already you know that electronegativity. Electronegativity, metals are having less electronegativity than non-metals. Okay, in periodic table from right to left, the character of metallic character to non-metallic character nature increases. Down the group, metallic character increases. Across the period, non-metallic character increases due to decrease in the size, and also they have more high electronegativity values. Non-metals have higher electronegativity than metals. Is it clear? Yes, this is right. Okay. Next one, non-metals have lower ionization enthalpy. Is it clear? Is it correct? Non-metals have low. Which are the non-metals here? Now you see hydrogen, helium, you leave it, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. When you move across the period, the non-metallic character increases, size also decreases. If size decreases, they are having more ionization energy values compared to other metal atoms. Non-metals are having highest ionization energy values, but here given lower ionization enthalpy values. Okay, this statement is not correct. Yes or no? Next, compounds formed between highly reactive non-metals and highly reactive metals are generally ionic. Is it correct? Compounds formed between highly reactive non-metals and highly reactive metals are generally ionic. Is it correct? Yes. Why? Because highly reactive metals are, give example, sodium. Okay, and highly reactive non-metal example is chlorine. Sodium readily donates its electron to the chlorine. Why? Because sodium is more electropositive element. It can readily donate the electron very easily to the chlorine. Okay, then chlorine is a non-metal, so it can take the electron very easily. Due to this, sodium after losing electron, it will become sodium plus. After gaining electron, chlorine will become Cl minus. Due to opposite in charge, they will form a ionic solid, NaCl. Okay, this is correct. This is also correct. Okay, next one, the non-metal oxides are generally basic in nature. Is it correct? Non-metal oxides are not basic in nature. It is acidic in nature. Why? Because you take carbon dioxide. When you dissolve this non-metal oxide in the water, it will form carbonic acid. Okay, non-metal oxides are acidic in nature. Metal oxides are basic in nature, but it is given in opposite direction. Non-metal oxides are generally basic in nature. No, non-metal oxides are acidic in nature. Why? Because this non-metal oxide, after dissolving water, it will form corresponding acids. Okay, sulfur dioxide, it will form sulfuric acid. Next, nitrogen dioxide, it will form nitric acid. Like that, non-metal oxides are acidic oxide, but it is given here basic in nature, though this is not correct. The metal oxides are generally acidic or neutral in nature. Is it correct? No, metal oxides are basic in nature. Why? Because you take sodium oxide, Na2O, after reaction with water, it will form corresponding hydroxide. Sodium hydroxide are basic in nature, but metal oxides are not acidic or not neutral in nature. Metal oxides are basic in nature, but it is given in opposite way. So this is also not correct statement. So what are the correct statements here? A and C. Here option 2 is matching. Okay, move on to the next question. Okay, here we have given two statements. The oxidation state of an element in a particular compound is the charge acquired by its atom on the basis of electron gain enthalpy. Consideration from other atoms in the molecule. Is it correct? No. So oxidation state, how you will consider? Suppose this is the sodium atom. Okay, how that sodium will get positive charge after losing one electron. And what is the oxidation state of sodium now? Plus 1. So it is addition of electron or loss of electron? Yes, loss of electron. So loss of electron means it related to ionization enthalpy. Gain of electron is related to electron affinity. So every atom. So now you see what is the oxidation state of magnesium after taking 2 electrons from this. So then magnesium will get plus 2 charge. But here given that the oxidation state of an element in a particular compound, you take any compound, for example H2SO4 you take. Oxidation state of element, then oxidation state of element you consider your sulfur atom, is the charge acquired by its atom on the basis of electron gain enthalpy. Is it correct? It is not based on electron gain enthalpy, it is based on their valency. Okay, it is not based on their electron gain enthalpy, based on group valency. Okay, how that group valency we can discuss. Every element in a particular period or groups, they're trying to get the nearest noble gas configuration. For example, you take sodium. Sodium atomic number is 11. Okay, to get stable configuration neon, nearest noble gas configuration 10, it has to lose 1 electron, because to get stable configuration, some elements lose the electrons. So to get 10 electron configuration, sodium loses 1 electron. Means chlorine last shell, what is the electron configuration of chlorine? This is chlorine atomic number is 17. So 1s2, 2s2, 2p6, up to here 10 is over, 3s2, 3p5. To fill this p subshell, it require one more electron. Yes or no? So it will gain the electron. This chlorine atom gains the electron, one electron, to get the stable configuration of 3p6. Okay, and the oxidation state depends on valency of atom. Okay, why this valency? We can discuss here how that valency will take the sodium, how it is taking +1 charge. Why? Because to get the stable configuration, it has to lose one electron. Why this chlorine gets negative charge? Why? Because to get the stable configuration or to get the fulfilled configuration, it has to gain one electron. It is based on the stability of atom, not depends on electron gain enthalpy. So is it correct? No. The statement 1 is not correct. Now you see here in H2SO4, oxygen valence is -2, hydrogen valence is +1. So based on this oxygen, this is a -8 and this is a +2. So -8 +2, to balance this, sulfur has to get +6 oxidation state. Okay, it depends on valency of other atoms, not depends on electron gain enthalpy. Next statement 2 you see here, p pi bond formation is more prevalent in second period elements over the other periods. Yes, second period means, what are the second period elements? Can you guess? Hydrogen, helium. This is the first period elements in periodic table. Second period element, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, so neon. These are the second period element. You observe the electron configuration of all the elements are 2s to 2p6. Means two periods. So first is a nucleus. First period is having only 1s. Second period, the second orbit has having 2s, 2p subshells. Means here we have 2s, 2p. Here p is there. In every element the p subshell is there. So they can form p pi bond readily. Okay. Now p pi bond formation is more prevalent in second period elements over the other period. So this is a right statement. Here statement 1 is incorrect, statement 2 is correct. So your option 4 is matching. So this is option 4 is the right statement. Okay, and move on to the next question. Now you see, match list 1 and list 2. If you don't know about melting point, ionic radius and delta H values, you don't worry. Just you see the atomic radius. Already we discussed this. For third group elements, atomic radius values already we discussed. Down the group, size increases, but exception case is there. Gallium, boron, after boron, aluminium has to come. Boron, aluminium, gallium, indium, thallium. Okay, due to poor shielding effect of d orbital of gallium, so gallium has less size compared to the aluminium. So this is the order. Okay, so which is more in size? Thallium is more in size. Next indium will come. So after indium, which one will come? Aluminium. After aluminium, gallium. So next boron. So thallium, indium, aluminium, gallium. This is atomic radius. Atomic radius. So which one is matching here? D is matching with, yeah, this is the 3. So D with the 3, here we have only one option. Okay, so this is our right option. In this way also you can select the options. Okay, now you see A with the 4 melting point. So boron has more melting point compared to all other elements than because of the gallium. You see gallium comes last year for melting point. Gallium is a liquid metal, it can readily melt by taking within your hand also. Okay, so gallium melting point is lesser than compared to all other elements. Okay, now ionic radius B with 1. Now this is the ionic radius, but atomic radius is somewhat different is there. So gallium, after gallium, aluminium will come, but here boron, aluminium, gallium, indium, thallium, like this, right? Ionic radius M plus 3. Next one is, yeah, C with 2. Delta H means ionization energy values. You can assume that ionization, kilojoule per mole indicates ionization energy. C with 2. Okay, so next boron, thallium, aluminium, gallium, indium. This is a enthalpy values in kilojoule per mole. Here we know that only atomic radius, then we can select this. Okay, in this way also you can take the answer. So move on to the next question.